This is FLOSS Weekly. I'm Doc Searls, and this week Jonathan Bennett and I are talking to Stephano Cetola, the Director of Technical Programs for RISC-V. It's a wide-ranging conversation. We touch on everything open about hardware and all the great progress going on with RISC-V, and that is coming up next.
Podcasts you love.
From people you trust.
This is TWiT.
This is FLOSS Weekly, episode 636, recorded Wednesday, June 30th, 2021. RISC-V. Hello again, good morning, good evening, or good whatever it is, wherever you are on the planet Earth and elsewhere. I am Doc Searls. This is FLOSS Weekly, and I am joined this week by Jonathan Bennett himself. There he is. And
hey, Doc, how you doing?
With a better background every time. Those rate your background things, I don't know if you've seen that. You know, the more books you get, the better rating you get. But you're looking good.
Oh, goodness.
There.
Yeah, well, yeah. At some point, I'll turn the camera and I'll show you the 6 bookshelves here. It is quite the sight. Yeah, the office is still... I have ones over there. I've got some too, but they're not. Yeah.
I have an air conditioner.
Trying to put the office together is a...
Yeah, it's and you're in Oklahoma, I assume. Still, you're not going to move that chair and all that stuff somewhere else.
No, I'm still here in Oklahoma. Corporate headquarters here at the home office, and good to be here from the heat and the humidity with you today. Yeah,
and here in New York City, where I am, I just turned off the air conditioner, which is this ugly thing in the background. It has dark curtains drawn across them, so you can't hear them. And there is some fan that you're probably not hearing, but there's a little semi-silent fan on the floor over there keeping me almost cool. So we have just a little bit of news to go into before we go into the show. And I know you have something to share. I don't have anything, so...
Oh, I do. So something that happened, I think it was this week, maybe right a week ago. Blender and Canonical announced that they're doing a partnership. So Blender being the big open source 3D modeling software, and people use Blender for all sorts of things. Canonical being the people behind Ubuntu, and Blender has never really had an official source of paid support. And Canonical, that's their bread and butter, is doing paid support for Ubuntu and different things like that. And so the people in the suits, I assume, got to talking to each other, and they've now announced that Canonical is going to start offering paid support for Blender, which I think is really a neat thing. For one thing, that these two groups are working together, but also that kind of gives Blender a new opportunity to get deployed in some places where paid support, the ability to pick up a phone and get a hold of an expert that can answer your questions, is necessary for doing business. So I think this is going to be a good thing for both projects, and it caught my eye, and I think it's interesting.
I would think it would expand Blender's marketplace as well. At least I would hope it would.
Yeah, I think so. I think having that extra assurance that you can get your problems taken care of will make it more palatable to, someone doing more serious work.
So our guest this morning is Stephano Cetola of RISC-V, and you're into RISC-V, aren't you? I think.
I have been. Well, that might be. I have been kind of following the story of RISC-V. I know what it is. It's a new processor, I say, totally open source from the ground up. And I'm aware of some people that are actually shipping hardware that is RISC-V. Sci-Fi is the big name there, although I don't think they're the only ones. And I've followed some stories where RISC-V is starting to show up in unexpected places, like inside some hard drives even. So there's a bunch of those things to ask about. But I am by no means a RISC-V expert. As far as the actual technical details of it, I am very much a neophyte. So this is one of those things that I would definitely not claim being an expert on.
Well, my own experience with RISC is entirely ancient. I worked with on the outside, but still pretty closely with Sun Microsystems on Spark, or at least making Spark a thing in the world, which meant dealing with dueling makers, There was Texas Instruments and Fujitsu and Cypress Semiconductor and a bunch of those guys, which may or may not even still be around at this point. But back then, RISC was all promise. Now it's all reality. So that's a gigantic difference.
Yeah, I think that is the great granddad once removed from RISC-V.
I think it's more like an uncle. Like it's not a direct. Nothing we're doing now is perhaps a direct descendant, but maybe Stephano can help us with that. So I'd like to welcome Stephano Cetola. He's the Director of Technical Programs for RISC-V International. He developed and managed numerous open source initiatives in software and hardware over the course of a 20-year career in tech. He helped form the Confidential Computing Consortium, a Linux Foundation project, bringing together hardware vendors, cloud providers, and lots of other people that take up an entire paragraph. I'd rather not read while we listen to actually talking to him. So welcome aboard, Stephano, to the show.
Thank you very much. A pleasure to be here.
Feel free to correct anything I just said or didn't say.
Oh, I think you covered it there. I'm excited to be working on RISC-V and to be working for RISC-V International. I did work for the Linux Foundation, bringing up the Confidential Computing Consortium recently with a bunch of different member organizations. I've worked on everywhere from firmware to embedded, and even did a little work in Java early in my career. So I've sort of seen the gambit of technology, and really excited to be at the base of open source, as close to the hardware as you can get, really, with the ISA.
Yeah, I'll start my part of this by asking something that just sort of follows on my own really limited and ancient experience. Is there a direct line of descent between RISC-V and what Sun was doing back in the 80s, which I think is when Spark was born?
Right. No, it's a good question. So the line of descent really comes from Berkeley. So the original RISC architecture that Patterson had envisioned has developed over the years, and the reason we're calling it RISC-V is because it is essentially the fifth iteration of several iterations. So I think there's some relationship in there somewhere, though uncle might be a appropriate reference. And I think part of what you see is in 2010, when Kirsta Sanovich and the other folks at Berkeley released RISC-V, and the world started taking notice of some of this new process of development, this open source ISA development. I think that's where things really took off and sort of went in a different direction.
So I'm curious. Let's start with the name, and I'll give you a softball to start with. What does the RISC part of RISC-V mean, and then where does the 5 come from?
Sure. Yeah, so that's a good question. The RISC part is the reduced instruction set computing as opposed to CISC. So the analogy that's always made is x86 computing, your typical Intel chip, is going to use a complex instruction set. So it tries to get as much work done as possible for a given instruction. The instructions are going to accomplish several different tasks. The concept of RISC was that in order to create a simpler base system, you can get less work done per instruction and allow the software and the compilers to figure out how to combine those simple instructions as efficiently as possible. So you're passing the buck quite a bit off to the compilers and off to software. So that's the RISC part. The 5 part, so you can go to the RISC-V website, and it actually lists all 5 iterations of RISC. So there was the original RISC instruction set that was developed, I believe, in the 70s. And then you can sort of step through time as folks at Berkeley expanded on that concept, adding different features. And so this is the 5th iteration. The name you'll find is Kirsta Sanovich, the PhD, the professor at Berkeley whose team worked on it. And 2010 is the date that the papers were published.
And then what's the big draw for RISC-V? Why, let's put it bluntly, what about it is so compelling that we're here talking about it?
Yeah. Now, so the reason we're here talking about it is because of how it's developed. I mean, there are plenty of RISC architectures out there. You've got, probably dozens to choose from. Certainly at least 5 or 6 popular ones out there today. Everyone knows about ARM, right? ARM is in all of our pockets. It's an instruction set that has certainly proven the test of time. And The difference in RISC-V is that we're developing this in an open manner, so completely open source. Membership in RISC-V International is free to individuals, and there are paid memberships for organizations. Once you become a member, you're allowed to contribute to the specifications that actually define the ISA. And so that concept, which is really quite new, it's something that hasn't been tried before, certainly not to this extent. That's really the difference between RISC-V and all the other options out there, and certainly why we're here talking about it right now.
Sure. And so let's spend just a little bit more time on the definitions, because there's a lot of alphabet soup going on. When we talk about an ISA, and to broaden this out a little bit, when we talk about RISC-V, RISC-V is not a processor. It's not a laid out bit of silicon. RISC-V is the ISA, if I understand correctly. What exactly is an ISA, and what do we mean when we say that?
Sure. So when we say an ISA, an instruction set architecture, we're really defining a contract. So you put it really well in that it's not a computer chip. It's the thing that comes before the computer chip. So before you build a circuit that's that complex, that does computation, you need a set of rules or contracts that are going to be guaranteed by that hardware that you're going to build. So we assume that our processors are all going to do very simple and complex operations. So like an add computation is something a processor should be able to do. But how it goes about doing that add or subtract is defined in the ISA. So the ISA is very much an English language prose document that you can read through, and certainly not a layman document, but one that will not give the implementation details of how something is done, but rather describe the process by which it is done. And many people talk about it as sort of the contract between hardware and software, because that's really where the rubber meets the road, so to speak. Once the ISA is defined, someone will then implement that ISA. So I'll pick on my friends at Beagle Board, who just recently created a product, the Beagle V. And so that board has a chip on it that's a RISC-V chip. And someone had to take that instruction set and implement it in actual hardware. And by doing that, they have to comply with what the specifications said. So as you might expect, there are tests that you can run when you're building your hardware to see whether or not you complied with that specification. So your processor needs to be able to do an add instruction, but it needs to comply with the way the specification defines that instruction. And as you might guess, there's lots of ways to do that and still have lots of bugs. So the idea that you're compliant with the specification by no means you created a great computer chip. It means you created a compliant computer chip. And so then there are a litany of tests, verification tests that need to be run to see whether or not that implementation actually works correctly. And so if you think about open source development from a software standpoint, from the standpoint of something like the kernel, there's a huge amount of testing that goes into ensuring that any change to any part of that hasn't broken something else. And when you take that picture even bigger into hardware, I think you start to understand a little bit of the complexity in what we're doing. We're making a specification that can be changed or extended. And as those extensions happen, you can't break anything else that's already happened because you've already got hardware out in the field. So if you think about the fact that when there's a bug in software, we can push changes out. When there's a bug in hardware, you can't. So there's really a lot of work that gets done to ensure that that specification, that ISA, gets not just implemented in a way that's compliant, but in a way that is actually verifiably correct.
So when we talk about this, obviously we've got the open source nature of this ISA. Are there any of these implementations that are open source as well? And I guess to make that a practical question, is it possible to right now buy an FPGA and download and run a RISC-V core, without having to pay anybody for that IP on that FPGA?
Yeah. Absolutely, and that's kind of what excited me originally about RISC-V. So as a student of technology and of hardware development, the idea that the ISA is open is great. And that really sets the foundation for what RISC-V is going to do. It's going to create an open platform that people can build, but they can build closed platforms on it. That's the way a lot of hardware companies make money, is by selling hardware that only they can build, or that they build the best. That being said, there's been lots of efforts, especially in the educational sphere, to make processors which are open source. So I'll pick on MIPS, because MIPS is what most folks have learned in school for the past 10 years or so, in that you can go get a MIPS implementation that is open source for educational purposes. And that was a real boon to universities. In teaching students about how a processor works, they need to be able to look at those transistors and look at those circuits and see how they're laid out. And so you can go get that from MIPS. Today, there are, I won't say hundreds, but there are definitely quite a few cores out there that you can go download and run on an FPGA that are completely open source and completely free. So a lot of the educational market is starting to look at that and say, okay, I'll pick on the Ibex Core. The Ibex Core is a really simple 32-bit RISC-V core that you can download to a relatively cheap FPGA, one that might only cost you $100, and run that and actually see how all of those moving parts work and learn. Even for a simple core, there's a pretty complex set of operations that need to happen to form a simple pipeline. And so in looking at that processor pipeline, the educational value is immense. But then when you think about that from a productization standpoint, when you don't need to pay any royalties, that's a great advantage in terms of creating a product. But even more than that, when you can change that hardware to do exactly what you want it to do without having to worry about, crossing over any patents or any copyright restrictions, that creates a product land map that is just much more broad than what we have today.
I want to dig into that idea about being able to change this, but first I've got to go down the rabbit hole of FPGAs just a little bit further. Are there any of the cores that can run on, I believe it's the Lattice FPGAs that actually now have a completely open source toolchain? And this may be outside your expertise, so forgive me if I'm digging too deep. But I'm just curious if it's possible to have a completely open source toolchain going from the RISC-V ISA all the way through down to the FPGA implementation.
Right. No, you're definitely speaking my language. That's as someone who's been working with FPGAs and learning about processor cores for a good chunk of my career. That's something that, it's sort of the dream, to be able to have everything from the ISA, the actual core that somebody built in Verilog, all the way through to the bit stream that's being loaded on the FPGA. I'm not going to claim that the entire stack of that is completely open source, but I can tell you that when you look at how close we're getting to that, it's certainly going to happen in the next few years if it hasn't already. The part I can say is that the bits that are open source are expanding to even beyond just to the things we think about in terms of the core, the bit stream, how the FPGA boots, like how it loads and brings that information into memory. But there are actually new languages out too that you can program hardware in. So Verilog is sort of the traditional one that's been around a long time. But there are other languages coming out that people are using to program FPGAs that are open source. So there are efforts to actually use Python to program FPGAs. And there are open source hardware description languages like Chisel that are starting to come out. And so I think what you're starting to see is folks like myself who did a lot of sort of the autodidact teaching yourself way of learning technology. You're seeing that drive of open source pushed down closer and closer to all the hardware so that educational process is possible. Because, as far as an FPGA goes, no one's going to make a ton of money if there's an open source bit stream. That's kind of how these companies make their money. But from an educational standpoint, it could be huge. And from the ability to improve those processes, it could be huge as well.
All right, so let's pick up that thread, because I know one of the things that's special about RISC-V is the way that it supports processor instruction additions, like custom processor instructions that can be added to the ISA when someone is actually designing a processor. So let's talk a little bit about that. 'Cause I know like x86 has been just kind of a constant march. And in fact, the Linux guys, they're starting to talk about x86 64 v2 as something that they have defined, and some of the distros are actually talking about only supporting that in the future. And I'm curious kind of what the comparison is to how RISC works.
Sure. Yeah, I think if you look at the x86 and ARM landscape, you see that march, right? You see extensions being added and features being added with each new generation. And the real power behind what RISC-V is doing is that they have something similar, a similar idea, these extensions. So for example, today, if you wanted to build a very simple processor core or a very simple processor system, you could use an RV64G, which just stands for like the general set of capabilities that a processor can do. And that'll get you a chip that's capable of running Linux. But let's say you wanted to go a little bit beyond that. The traditional way of doing that is you would find a coprocessor to do the thing you're looking to do. So let's say the thing you're looking to do is security. You would go find a coprocessor that did the security thing you were looking for, and you would essentially duct tape it to that processor. And now you'd have a product that had a basic application level processor combined with some security feature. Well, currently, RISC-V is working on our cryptography instructions. So this is an extension to that base instruction set. So it builds on top of that, much like you see coming out of the x86 and ARM world as they build on top of those instruction sets. The differences are that the cryptography extension is something that can be implemented and then designed in a way that can be customized to your original purpose. So it gives you sort of the flexibility to say, well, I need to add this extension, but the way I'd like this extension to work from an implementation standpoint is very specific and allows you that flexibility.
So I have one. I kind of probe open hardware a little bit farther. It seems relevant to me that the x86 architecture and you mentioned MIPS earlier, and now Apple has its new CPU, the M1, and it seems to me that all of those have been full of secret stuff that's the intellectual property of the maker, and with presumably a lot of stuff in there that nobody else can get at. And so I'm wondering a couple things about that. One is, you may have already answered this, but I'll just ask it anyway. Because of the way the ISA is done, are all RISC-V chips by definition open? And are they required to be? And if not, what can makers put in there that might be closed and proprietary that we want to be worried about or just know that's there?
Right. No, those are great questions. And yeah, just to be clear, any implementation that's made can be made completely closed source. So there's no, the ISA does not imply that the way in which you implement it needs to be done publicly. So the code that's written, the Verilog or whatever RTL code is written that defines how that processor works, can be completely closed source. And there are a lot of implementations out there that are already closed source. So many products ship with closed source cores. We mentioned hard drives earlier. Hard drives are a great example. Western Digital has moved to completely RISC-V cores in their products. So all those microcontrollers are closed source. Western Digital doesn't need to show the world how it's making its products. But there are lots of capabilities in terms of making stuff open source. So like I mentioned, there's the Ibex Core, but there are lots of cores out there that are opening up their code and allowing the development to happen in an open source way. In terms of what can be hidden in there, well, I think the power behind the ISA being open is that you understand how the fundamentals of that chip work. But from an end user standpoint, I think it really gives a lot of credence to the folks who are trying to create open source cores, because unless the source to those cores are open source and the source code to those products are open source, really anything can be put in. There's no limit to the way in which you design the circuit. And so, yeah, from a security standpoint, building an open source RISC-V core, while the benefit may not seem immediately obvious from a productization standpoint, from a security standpoint, folks who are interested in buying products that they can see how all the bits work and know that nothing is hidden in there. I think that's really something that's powerful that hasn't been available before.
Yeah, actually, I was thinking more about the way that the CPU itself is designed and made, and what's open about that. In the sense of open hardware has no mysteries in it, or should have no mysteries in it. In other words, you can look at it. You know what these guys put into it. I know why they close it. They want their own special sauce in there. They don't want anybody else to knock it off. Intel famously fought AMD for a zillion years about knocking off the reverse engineering, essentially the x86 architecture. And so I'm wondering if we're going to see, because of RISC-V, less secretive stuff in the iron itself, and how that's done and what it's used for.
Yeah, I really hope so. I think so. I would refer to a project that Google started, and that's now being run in. I'm not actually remembering what the group is that's heading it up now, but it's called Open Titan, and it's a security chip that specifically uses a completely open source stack. So when you have a system that you're attempting to make secure, a hardware root of trust is a term you'll hear a lot. Essentially, there needs to be some piece of hardware that's going to guarantee that the very fundamental things that are making your system secure stay safe. So, for example, the keys that the cryptography algorithms are using to do their work need to be in a place that's guaranteed to be accessible only by the appropriate entities on that system. Well, historically, those roots of trust have been closed source. Companies had their special sauce and would claim that their product was more secure or faster or what have you. The fact that there are now open source options to that based on RISC-V means that when you buy a system, you can know from looking at how the system was built that it was built in a secure manner, and you can actually examine how each part of that works. And I think that's a great example of where I think folks are starting to understand there are pieces of these puzzles that we put together that there might be more benefit to them being open source than to closing off the source, patenting something, claiming that you're faster or that you're more secure. I think that's a trend that we're going to start to see.
I'm going to jump back in and talk about something that's been in the news very recently, and that is the 10,000-pound gorilla in the room. Intel has suddenly come out and expressed a whole lot of interest in RISC-V, and particularly in Sci-Fi. I'm curious if you can comment on that, and if you have any thoughts on that you want to share.
Sure. Yeah. No. It is very exciting to see. So Intel has been involved. They've been involved in Sci-Fi as a company for a while. This isn't anything really new or unexpected. But as someone who is keeping sort of an eye on which companies are showing interest from an implementation standpoint and which are showing it from a business standpoint, I can say that I was really excited to see that Intel was interested in building RISC-V cores. I think I was excited to hear that announcement from Pat. And I think that a lot of positive things could come from that. But I can't comment as to any possibilities that might be coming in the next few weeks. I can just say that I think it's no surprise.
Okay, I figured there might be some insider knowledge there that you weren't quite at liberty to talk about. So, again, this may be along the same lines. Intel is actually talking about potentially putting some RISC-V cores in some of their future processors, aren't they? I think that's something that's been talked about publicly.
Yeah, I think one of the things that most people don't understand is that Intel's in the business of creating, not just CPUs but platforms, and so some folks may know that when you buy a system, an Intel-based system, you are not just running an x86 processor. You are running probably several processors on that board, especially if it's a server class board. And so I'll use the BMC, the board management controller, is probably the one that gets picked on the most. So that's a unit that essentially allows the management of large scales of different processors to be managed. Even if the board isn't booted up, you can still manage that board, manage its power, its state, and that has historically run using an ARM chip. Many folks will know about the other coprocessors that will run alongside the main CPU, the main processor, and that's sort of part and parcel for creating a complex system. And so the idea that they would throw different cores into different setups is really nothing new. A TPM, Trusted Platform Module, is a common device that's added, and sometimes it can be a simple microcontroller, but sometimes it can be a full application processor. And so which cores go on those products is sort of up to the discretion of the designers. Now, the idea that when building these complex systems, there are cores available that don't have any licensing attributed with them, I can see that as being very attractive. And not only that, but for companies like Intel that have the resources behind it to have the R&D to create something new and the manufacturing capability to actually produce that new thing, it really, there's amazing things that those kind of companies can do with this instruction set architecture, because they can spin their own R&D research around an idea, prove it in their verification, and then push it out in their manufacturing. And like I said, RISC-V does not require those things to be open sourced when you create those products. So they can keep their sort of, umbrella of patent around that and create a product that really meets their specific needs.
So we do have the live chat room, and we have a question from Virgil, and I'll paraphrase. He observes that certain things, when you buy like an M1 chip from Apple, you have two options. You can either have 8 gigs of RAM or you can have 16 gigs of RAM. And I think the question is, how flexible is the RISC-V architecture there? He had just give us a little bit more information about what he's asking. So, and I'm curious about this too. Like how low can you go with RAM on RISC-V, and how high can you go? Is there an upper limit? Is there a lower limit to what makes sense?
Sure. Practically speaking, there are no limits set. The lower limit will be defined by, what software you're trying to run on there, or what firmware or assembly code you're running. For upper limits, I think one of the things that you'll notice about RISC-V is that you see a lot of people developing products, but then when you look back at the ISA, you'll say, well, where is that mentioned in the ISA? Like, I see they're doing this really complex MMU, but I don't see an MMU anywhere in the specifications. And that's a great example of how folks can take the current state of RISC-V and develop products based in any way that using whatever they have at their disposal. So lots of folks have already produced chips which take advantage of much larger capabilities than what anyone would be able to do without a development team of hardware engineers on their staff. And so, yeah, I think the limits of RISC-V currently are really up to the limitations of what the implementers are able to produce. But the base ISA itself will allow essentially anything. It really comes down to what resources you have at your disposal when you're implementing that chip. So if you're a large silicon manufacturer, you're going to be able to create a very enterprise level, server level chip. Whereas if you're, a small startup, that might be a little bit more difficult.
So we got another interesting question in Discord this time from Just Nick, and he first jokes and says, this just wants me to start running my 512K RAM chips again, and then he says, that's actually an interesting thought. Could this be theoretically run or integrated on older hardware to make it new again, like Linux has done with software? I'm trying to think through exactly how this would work. So the way I would imagine this is you take some old motherboard that you can't get a processor for, and you would spin up your own RISC-V processor and drop it in there. I think we're kind of playing at the edges of what's practical, but I suppose you could do something like that, couldn't you?
That would absolutely be possible. I think from a nostalgia standpoint, it would be a lot of fun, and it would certainly be feasible. The amount of things that we can produce now as hobbyists and makers, it's amazing what we can get done. So yeah, the idea of fabbing your own processor was definitely not something that you would be able to do 10 or 20 years ago. But today, that is definitely a reality. And assuming you have the pinout of the chip that you're trying to reproduce, the ISA for RISC-V is open source, and you can take advantage of some of the chips that are some of the cores that have already been produced and simplify them down to your needs. It's funny, that's kind of going in the opposite direction that most people would take it. But I can't imagine it would be easy, but it would certainly be easier than going in the direction of making it more complex.
Yeah, and it's kind of interesting to think. We see stories every once in a while, especially over on places like Hackaday.com, where you have guys that are attempting to do things like chip manufacturing and lithography in their garage, and some of these techniques are actually coming to the point of being, nobody in their garage is approaching 5 nanometers, but you can start to replicate some of the old chip fab nodes, and boy, it's not actually totally infeasible that someone could literally make their own very simple RISC-V chips in their garage within the next few years.
I would definitely say that if anyone is interested in or currently working on that, I would be more than happy to talk to them.
All right. Now I'm curious. We've got Raspberry Pi. We've got the Beagle boards, the Beagle Bone, and all of those things. Are there hobbyist boards for RISC-V that are available right now? I know there's been a lot of work done on running Linux on RISC-V. Are there the boards out there? Can I go to Amazon or SparkFun or whatever website and order a board that's RISC-V and run Linux on it, get it shipped to me? Is that something that's possible now?
Yeah, absolutely. Yeah, that's something that I'm really excited to be able to talk about, because for me, when I was first starting off in my journey through RISC-V, the big question was, well, where's the hardware? We don't have any hardware yet. So we do have microcontrollers that are really easy to come by. You can go to SparkFun and download a Red 5 board, which I believe it's a 32-bit microcontroller that will essentially give you your sort of introduction to the RISC-V world, and that you'll be able to write some C code and blink some LEDs. But even with the chip shortages that we've been seeing, we have been able to launch a couple of products in terms of getting some hobbyist boards out there. There is the struggle of keeping the price low. Like the Raspberry Pi, it's hard to beat that price point. But we have gotten a couple of boards out. So I'll sort of start with the more expensive ones and then move our way down to the ones that are a little more attainable. So there is one of the more complex boards is a Polar Fire. So Polar Fire, the Polar Fire SoC, I believe it's the Icicle development kit put up by Microsemi. And this is actually a hardcore SoC on an FPGA. And it's got a lot of really interesting security capabilities. So I think for folks who, I believe the price point there is around $250. So, for a FPGA development board, it's still pretty reasonably priced. So the idea there is that if you're someone who's really looking to sort of have all the bells and whistles and really have a lot to play with, that's a great place to start. And it does give you a hardcore SoC rather than a softcore. So you're not actually loading the code onto the FPGA to have your RISC-V core. It's already embedded on there in the fabric. So that's one of the more expensive ones. We did just have the folks from Beagle Board did just release their Beagle V Board. That is the first hobbyist RISC-V board that broke beyond the $200 barrier. So I believe it's $150. It's been shipped to sort of the beta crowd, and I'm lucky enough to have one and being able to play around with it. And it will be shipping in quantities soon. And I think, while it's a little bit more on the expensive end as far as hobbyist boards go, I think that it'll have a great following just because it is much more powerful than a lot of the options that you have out there. And I think people are willing to to sort of grin and bear the price point for now, in that they realize that it takes a long time to bring the prices down on these products. And so, the fact that the ISA is so new and folks are just starting to build products, I think it's just seeing a lot of attention for that. And then the other one that's out there right now is the D1 board. That one, I believe, is shipping in quantity soon. And I believe that price point is closer to $100. But that one I can get you more details on.
All right, and then we had a question from IRC, which I laughed at first and then realized that no, wait, this probably is something we should ask about. Eric Duckman says, "Can it run Windows?" And of course, of course not. Of course not.
That's
and then I think,
question.
wait a second. You can install Windows on the Raspberry Pi now. Microsoft has pushed Windows support out for ARM. This is not entirely out of the realm of possibilities. So is this a conversation that has been had?
So I would say it's definitely a conversation that's been had over beers. And that many of us have discussed, what needs to happen and, when will it happen. It's obviously it's completely feasible. It's not something that's beyond the realm of capability. It just takes the firmware piece to be there. That's probably one of the bigger pieces that needs to happen. So once once Microsoft has released their RISC-V build, when that day comes, there's the idea that it is going to have to run on some piece of hardware, and the bridge between that software and hardware is firmware. And so we do have support for EDK2, which is the firmware that runs on most laptops and desktops that you buy today. So I will say it's kind of bare bones support. So, EDK2 is running with RISC-V. We do have that firmware as a possibility. It is not fully fleshed out. I would not say that it would currently run Windows flawlessly. But the fact that work has already been done, I think, is a step in the direction of really normalizing the way we look at the software landscape for RISC-V.
So I want to ask about your training program, your training partner program, because that's usually a big part of what you're doing as an organization and maybe what you're doing personally. There's a lot of this outreach that seems to happen. So I'm wondering if you could tell us a little bit more about that and who it's for and what you're training.
Sure. Yeah, absolutely. So the efforts of RISC-V International, and just as a refresher, so you have RISC-V, the ISA, and then you have RISC-V International, which is a nonprofit, much like the Linux Foundation, and whose goal is really to be essentially the keeper of the ISA, to create the standards and the specifications that run it, and then also to build up an ecosystem around it. So we really do sort of shepherd all of the projects, not just the technical ones that take up 99% of my day, but also the non-technical ones, the ones around building community and around building training. And so I actually work with the Linux Foundation training folks in developing different courses and sort of the technical oversight of how that works. There's a couple of courses that are out there today that are available for free. Our 110 course is kind of near and dear to my heart. I developed that course with a coworker, Jeff Rowe, who's currently now at Red Hat. But it was an effort for us in that we saw this gap in knowledge, where that distinction I just made between RISC-V, the ISA, and RISC-V International wasn't really well understood. And so we wanted to develop a course that just walked people through the basics. And we wanted it to be more than just a history of, here's where RISC-V, the ISA came from, here's what RISC-V International is and how it works. But we wanted it to go kind of the next step and talk about the base ISA and talk about, what makes the instruction set different than others. And actually end the course. We wanted the course to culminate in a Hello World application, because we figured, you'd get 90% of the people that are going to be looking at this are already interested in technology. They're already probably technical themselves. If they get to the end of the course and they can actually open up a text editor and write some code, it'll feel more like an interactive experience rather than just studying the history of something. So I think the 110 course is really great in that it applies to a really broad audience. There's no coding knowledge required. You don't actually need to write the code. You can watch the videos at the end and experience my poor attempts at assembly programming. But the great part about it is that it applies to so many people, whether they're engineers, they're hardware or software engineers, whether they're just technophiles who are interested in learning more about what this new technology is and how it works, or whether they work in industry and maybe they're a project manager or a manager and they've heard this term 100 times and they're sick of going into meetings and not knowing what any of that stuff is. There's really only so much you can get from Googling around. So the 110 course is a really great intro to everything from what the ISA is, what the organization is that works on it, all the way through to here's how it actually runs. And here's how you might say, hello world in assembly. So that's a course that I'm really excited about. And then the 111 course is sort of the natural next step. So that's the Build a RISC-V Core course. Both of these, by the way, are completely free. So there's no money needed to take them. If you do want a certification that says you've taken it and you've passed the exam, I think it's $50 or something like that, or $100 for the certification. The 111 course, Build a RISC-V Core, was done by Steve Hoover, who's out of Redwood EDA, and it's really amazing to see the work he's done. So once you're done with that intro course, your next question is going to be, okay, how do I go about building my own core? How do I take advantage of the fact that this ISA is open source and actually create a core? Well, the barrier to entry there is really huge. I mean, I don't know how many folks listening or watching have tried to write Verilog, but it's not exactly a low bar to entry to start creating your own circuits. Steve's actually got his own EDA system called MakerChip. MakerChip is online, it's free for educational use, and it's essentially, for software folks in the room, it's essentially an IDE, right? It's a place where you can actually write the code, where you can simulate it and run it and actually debug it all in one place. And it actually uses transaction level Verilog. So it uses, instead of the sort of the Verilog that everyone's been using over the years since the 80s, it's a much more straightforward way of thinking about how we build hardware. And so I think when you look at that barrier to entry, by using this online ADE, that saves you from having to not only buy an FPGA, like you can actually just hop online and watch your code simulate. You don't have to buy an FPGA. You don't have to learn a complicated software suite. You don't have to figure out complex test benches to run your code. You can really just hop online, and within 30 minutes to an hour, you're creating circuits. And I think by lowering that barrier to entry, it's a really great way to take folks who may not be hardware engineers, introduce them to RISC-V, and then actually have them build a core to see what that computation looks like. And the course itself is really well laid out. He's done some great videos that sort of walk you through the process, and it's really an impressive experience.
So I was just saying on the back channel here that I want to start my life over so I could do some of this stuff. Also learn other languages, play guitar, and a sport. But anyway, but this sounds like a lot of fun, actually. And so I want to ask a bit more about the organization itself. Because when I look down the list of members, it kind of looks like, oh, it's everybody. I didn't know that this many exist there. You've got the premier members, the strategic members, and you like to scroll past the entire alphabet, like in the dictionary, and then you get down to the community members. And I'm also wondering if there can be individual members. Can that happen too?
Yeah, absolutely.
So tell us about what is that ecosystem? It actually looks a lot kind of like Linux Foundations as well. And I'm wondering if that's part of if there's a Venn to this ecosystem as well.
Yeah, certainly. Yeah, it's set up like a typical nonprofit in terms of supporting an open source project, and that there are paid corporate memberships. The highest level is Premier, and then the next level is Strategic, and then there are community memberships as well. So I always like to start these conversations by saying there's no need to be a member in RISC-V International to be part of the community and to do work and to learn. Like the only thing that being a member of RISC-V International does from the standpoint of the individual is just allow you to work on the actual specifications. But there are folks working every day on improving GCC and LLVM, working on QEMU, all this software that helps the ecosystem run. There are people out there building cores. You don't have to be a member to do any of that work. All of that can be done, and you don't have to be a member. So that's my anti-sales pitch. Now that I've given that. For corporations, there's 3 levels. There's the premier and strategic. And then for nonprofits and educational institutions, there's the community membership. The idea there is that by developing specifications, we do need to ensure that everyone has the same IP policy and the same set of regulations that they agree to run by, such that we can run the organization in a way where the board of directors can guide the business end of the efforts, and the technical steering committee can guide the technical end. And this is the way you'll see a lot of these nonprofits laid out at the Linux Foundation, Eclipse Foundation, Apache. This is a pretty standard way of running things. The thing that's a little different about RISC-V is we do have individual memberships, and it's really to the community and to our advantage. So I'll give you just my technical perspective. When I'm working with all the different task groups, the work groups that actually help to create the specifications, that the special interest groups that look into what's the future for functional safety or for machine learning. Without those individual voices in the room of folks who aren't part of a corporation that's contributing to RISC-V, but just an individual member that's contributing, we really lose out on a huge chunk of knowledge. And so the individual membership is open to anyone. It's completely free. And we have a lot of folks who are currently contributing both to the specifications and then also to the efforts, like I mentioned, the special interest groups that are just driving the what comes next in RISC-V. So the ability to participate is really impressive, and that ability crosses over too to the non-technical end. We have individual members who do developer outreach and advocacy. We have an ambassador program that helps to give folks credit for all the work they do in terms of leading different efforts in open streaming, open sourcing things like the bitstream to an FPGA. And we've also got a development partner program where there's a lot of work, like I said, that goes into ratifying these specifications, ensuring that those specifications actually meet some stringent standards. And there's a lot of work that gets done both in academia and in corporate America, or in corporations, where you see a huge amount of equipment needed and labs, and all of that can be sort of honed together through these different groups that are available to not just corporations but also the individual. And I think that's really exciting. It's exciting to see test suites being spun up where huge amounts of hardware are needed, the resources of an entire several academic institutions, funds and resources, and also individuals able to participate in that activity. So that's really exciting.
So I've got to jump in. A question occurred to me a few minutes ago, and I wanted to ask. I do not do assembly language programming, but I hear from people that do that the old the x86 instruction set has, because it's existed for so long, become quite a mess to try to program in. And I'm curious with RISC-V, because it's kind of new and you guys were able to start without any of that cruft, is it a better experience for trying to do assembly language programming?
Yeah, I think for those out there who are assembly programmers, I think it'll be very similar to the experience you have with MIPS and with ARM, in that, as someone who's written a bit of assembly, albeit sort of cringeworthy assembly, x86 is just a whole different beast. Most people learn on systems like MIPS or like ARM. And when you first experience debugging an x86 assembly program, it is kind of like being thrown into the deep end of the pool with a couple of weights tied to you. I think anyone who's programmed an assembly for MIPS or for ARM, I think you'll find the RISC-V assembly is pretty similar. You won't have any trouble making that switch.
And for anyone who thinks, oh, surely no serious work is done in assembly anymore. Well, no, there's quite a bit of serious work that gets done in assembly these days.
Yeah, indeed. I would encourage them to go look at the Linux kernel and see how many assembly files they can find.
Yeah, Doc, did you want to?
Yeah, so I have I'm remembering back when I was working for Sun on Spark 1,000 years ago, I was at a conference where I encountered Larry Tesler. Unfortunately, he's gone now. He's the guy who invented copy and paste and at Xerox PARC and worked for Apple for many years. He was working for Apple at the time. And he was quite confident that, and this is the 80s or something like that RISC was going to take over, and that Intel, this is right after Andy Grove of Intel told me, we sell more chips in an hour than Sun will sell in a year. And just putting down Spark, basically, and because I worked for Spark. But Larry was saying, no, RISC will win because it'll completely obsolesce what Intel's doing. Well, later, Apple goes with Intel's iron. Now they finally have their iron, whatever it is, and RISC is finally maturing as a thing. So I'm wondering, that's 30 years ago, and now it's kind of like, well, ARM is huge, obviously, that's a RISC thing, and ARM was Acorn back then, and nobody called it, ARM was a minor thing, it was all about Acorn, and little outfit out of the UK. And you mentioned MIPS earlier, but part of the way we made Spark happen is we picked a fight with MIPS. We said they're the real enemy, and it elevated them hugely. And because all the press, all the EE Times, and all those guys said, "Oh man, there's a fight going on between Spark and between Sun and MIPS," when in fact the real fight that was going on, it was between Motorola and Intel. But we wanted to pull attention away from that, and a lot of people at MIPS got rich because of it. Good for them. Anyway, I got nothing. But anyway, but I'm thinking out. Okay, it's 10, 20, 30 years from now. Where are we at then? And how do you see that evolving?
Yeah, reading the tea leaves that far out, it's
that's hard.
It's quite an endeavor.
Larry Tesler didn't do a good job of it. Now he's gone. So,
Yeah. So I guess the thing, in the time that I've sort of been part of the tech opera that is this world, I think the thing that I see happening is much more the drive of open source than any one ISA. And so sure, RISC-V is the first one to the table with an open source ISA. And I think the concept there is that what we've learned over the past 30 years is that the development of software being done in an open source way is really the key to success. And not just for, startups, but for large companies as well. I think what we're learning is that hardware can't be done the same way as software when it comes to open source. Something needs to be different. So you can't just copy and paste what we did with the software into hardware and assume it's going to work. And what I'm really excited about is being part of the RISC-V process of learning how to do this by trying. And I think what that will gander over the next 20 or 30 years is that process that we all take for granted in software. We just take for granted the idea that anyone with a laptop and an internet connection and some free time can contribute to the Linux kernel and change the way an operating system that runs on most of the computers that we have in the world, that kind of difference can be made. And I think as we learn how to do that in hardware over the coming decades, I think we're going to see that becomes the standard rather than looking to one ISA. Because at the end of the day, most folks don't care how the hardware is doing the computation. They expect an ad to happen. They're not really all that concerned with how the ad happened. But what we'll start to learn is that these ISAs are integral to how the open source work happens. And so as we forge forward in developing this ISA, I think that open source methodology will be really the thing that comes away as the prize, rather than, how the ad was operated on or, how we implemented a fence. I don't think that'll be the thing that goes down in history quite as much as how we went about doing it.
It's funny, when I was working for Sun way back then, the big thing in operating systems is they had their own operating system, and they were trying to reconcile that with AT&T's SVR4, System 5 Release 4. The deeper you get, the longer the acronyms are. They're more four-letter acronyms about all this stuff, including RISC and CISC. But Linux won, and the reason it won, it seemed, and that struck us when we started Linux Journal back in '94, when Linux hit 1.0 was for the developers was it was easier. It was just easy, and it seems to be that, and as Linus has put it, he put it in the title of his book, it was fun. It was a lot more fun to just look at this really nascent operating system and just, it's POSIX compliant. I can do some stuff with that. And there's just this kid running it sort of, I think I'll just do something with that than it is to look at the politics of it all. And it seems to me like you've kind of masked some of the politics as well in the way you described how this works. I mean, you can't get people involved unless they're already cooperative. That's sort of an interesting angle on it. It's like this is a space for cooperation and not a space for you to have political fights. And
yeah, that's
yeah, go ahead.
Yeah, that's definitely one of the keys to the work that we're doing and how it succeeds. Politics is all left sort of at the door. The goal is to create a whatever that extension or whatever that standard is. The goal is to create one that works well for everybody, not one that meets the needs of the few. And I think that's the thing that allows these companies that are normally competitors, along with a really complex antitrust regulation, to come together and actually get work done in a way that's going to benefit everybody. And I think watching that happen at the hardware level after having participated in the software level for so long is really humbling, because it's a thing that can actually change not just the way in which our products work, but the actual products themselves, the physical products. And it's that tangible aspect that I think is really exciting.
So we're close to the end of our hour here, and we always close with 4 quick questions. The first, and it has to be brief, is there any question you'd like us to have asked that we haven't?
No, I think you definitely covered all the bases.
I can't believe that all is that small a number, but yeah, that's good. I'm sure there are more. The second is, do you have anything to say about blockchain?
I guess I would say that there is a special interest group for RISC-V that works on blockchain. So if anyone has any questions, feel free to ask that group. They know a lot more than me.
Well, that may have been that unasked question. And the last 2 are, what are your favorite text editor and scripting language?
Scripting language has to be Python. And for text editor, as long as I get NerdTree and Tmux, I'll use Vim any day.
That's fantastic. Well, thanks so much for a great hour, Stephano. It's been great having you on the show.
Yeah, thank you very much
for having me. Everybody, we'll have to have you back because it's been a great one. On the back channels, people say, yeah, this is great. It was a great show. So
absolutely.
Appreciate it.
Thank you. Great to be here.
Yeah. So Jonathan, that was a fun show.
It was.
I learned a lot.
I enjoyed that a lot.
I learned a lot. Yeah.
Yeah, there's a lot going on in the RISC-V world, and a lot of unexpected people are excited about it, like Intel and some of those guys.
Yeah. I wouldn't have expected that, but that's cool, and it's also interesting to. It's been fun for me because I kind of go back to a period in my life when I cared about FPGAs, for example. Mm-hmm. and I'm wondering how many people, even in the Geekback channel, know what a field programmable gate array is. Probably they do, but
I would assume so. I mean, we talk about it every once in a while because there's a lot of, especially when you're talking about kind of the processor hardware, there's a lot of open source work that kind of depends upon FPGAs in one way or another.
Yeah. So I want to make a note before you plug Hackaday to say that I see Hackaday sourced more and more by other people, which is sort of is your subscribership growing there?
I think it's been fairly steady. I take a look at the stats every once in a while, but I pretty much stay busy trying to make my little tiny bit of the content. Hackaday is pretty cool though because it's so many enthusiasts and engineers that frequent it, and we were talking about this the other day. They call us out on any BS that they see, and so they really our audience there keeps us honest, which is part of the fun.
I wonder sometimes especially with geeks, if some of the seeing of BS is like, that looks like BS to me, but it may not be. It's kind of like those little eye tests or hearing tests. What'd you hear there? Did you hear that or not? But if there's a suspicion, there's an assumption of smoke and therefore fire. But I don't know. I'm not on that one. So, I subscribe, but I don't know. But I'm not enough of a geek to call BS on anything. So.
Well, it's one of those things. Your mileage may vary. For one person, It may be a very useful conversation, and for somebody else, oh well, that's just a bunch of buzzwords put together. And, okay.
So, any last words on Hackaday or anything else you want to plug? Since I already put that one on the table, there might be something else.
So Hackaday, go check it out. Every Friday morning, my security article runs, and obviously, stay tuned to that for what's been going on during the week in security news. And then I guess the only other thing I have to mention is you can go follow me on Twitter at JP_Bennett and kind of get an inside look into what I find interesting, and feel free to point things out to me there that you think I ought to know about.
Well, that's been fantastic. So thanks a lot. It's been a great show, and thank you to everybody who's tuned in. As always, I'm not looking at who's on next week. I'm sure it'll be good, and we will see you then.
You know what's fun? Android. You know what's even more fun, though? All about Android. That's my show, Jason Howell, along with my co-hosts Ron Richards, Florence Ion, and we welcome guests on each and every week from throughout the Android ecosystem, developers, Googlers, journalists, people who are all geeked out about the Android operating system. We tell you everything you need to know. twit.tv/AAA every Tuesday. We'll see you there.